to select the standard case box, a drop-down menu provides 16 standard fault cases, which can be divided into 4 main groups. These are solid or single-point bonded single-core cables, individual or overall screened multi-core cables, cross-bonded single-core cables with and without earthing conductors, and overhead lines. Note that SC stands for single-core cables and MC stands for multi-core cable. A schematic diagram of the arrangement selected is shown. Nodes are the numbered circles which are connected by the elements or the lines to form a circuit. I will explain the schematic shown for standard case 1, which is for 2 substations connected by a screened single-core cables with the screens bonded to earth at both ends. The schematic diagram shows a faulted phase conductor connected between nodes 1 and 4. Only one phase conductor is shown because it is a single phase to earth fault being simulated. There is a short circuit connecting nodes 1 and 2, so between the phase conductor of the cables and the earth. The local earth grid, which is the earth grid under study, is named EG local and is connected between nodes 2 and 3. When there is a fault, then a portion of the fault current which is fed from the faulted phase will return to the current source via EG local, which gives rise to the unsafe touch and step potentials, and another portion will return back to the current source by the earth cable screens, shown here as screen 1, 2 and 3. It turns out that due to strong magnetic coupling between the faulted phase conductor and the earth cable screens, that the vast majority of the fault current will return via the cable screens and not through the local earth grid, which provides a relatively high resistive path. This then is the beauty of the fault current module, that it can help reduce your actual earth fault level by so much that it can make the safety compliance of your earthing systems very easy to achieve. You need to provide certain basic information about the installation. You'll need to enter the maximum earth fault level as fed from the remote current source. The local and remote earth grid resistances need to be entered. The local earth grid resistance can be calculated inside SafeGrid itself, since it is the grid under study. The remote earth grid resistance can be taken from measurements or simulation, but it can also be estimated, since it turns out that the remote earth grid resistance has little influence on the final results. The length of the cables or the overhead line connection needs to be provided. Note that this is the overall length, including for cases involving cross-bonded cable connections and multi-span overhead lines. The soil electrical resistivity is a single value signifying uniform soil. This value can be taken from what you know about your soil model and should be conservative. So, for example, if it is a multi-layer soil resistivity model you're using, then you should use the highest value, or you should use the bottom layer resistivity of your soil model, because this layer has the most influence as it extends to infinite depth. This is up to your own engineering judgment. Since the fault current distribution depends on the mutual couplings between the elements, then you will need to enter the physical relative positions of the cables or the overhead phase conductors and the earth conductors. You will also need to enter the AC resistances of the phase conductors and that of the cable screens or the earth wires. On the right side, the fault current results box can be seen, showing a complex magnitude and a percentage of the total fault current for each element. Each element is given a name with 2 values contained in the brackets, with the left value denoting the starting node number and the right value denoting the end node number. This helps determine the direction of flow of fault currents based on the sign of the magnitude of the current value. As can be seen for this example, only 4% of the total current will enter the local earth grid during a fault. In the next video tutorial, we'll be going through configuring settings under the soil model module.